So welcome to Tipping the Scales, a climate conversation series hosted by the Global Returns Project. Today, I'm honored to be joined by Professor Joanna Haigh. Jo was co-director of the Grantham Institute at Imperial College London from 2014 until her retirement in 2019. For the previous 5 years, she was head of Imperial's Department of Physics. Jo has been president of the Royal Meteorological Society and a lead author on the Intergovernmental Panel on Climate Change. She's a fellow of the Royal Society, the Institute of Physics and the City and Guilds, and an honorary fellow of Somerville College, Oxford. Jo was awarded the Institute of Physics Charles Chree Medal and Prize 2004, the Royal Meteorological Society Adrian Gill Prize 2010, and was appointed CBE in the 2013 New Year's Honors. Jo, we're so excited to have you on Tipping the Scales.
Well, thanks for all that, Jack. It's a pleasure to be here.
So, Jo, my first question is, what is something that most people don't know about the state of Earth's climate today or the state of the planet?
I think most people understand that we've got global warming due to increasing greenhouse gases in the atmosphere, but I think most people don't understand quite how much they've been increasing. So if we look back at the carbon dioxide in the atmosphere, that CO2 is the main greenhouse gas that humans are producing that's causing recent global warming. That hasn't been as high as it is now for at least 3 million years. Now that's a big number and it probably doesn't mean very much, but it's a very long time ago. I mean, before mammalian species had evolved to what they are today, and indeed humans didn't evolve till 200 or 300,000 years ago. So it's a very, very long time ago. And if we look and see how CO2 has changed just over the last 150 or so years, it is huge. So over that 3 million year time scale, the CO2 didn't go above about 280 parts per million. Those particular units don't need to worry us too much. But if we look and see that was until about 1750 or so, late 18th century, when humans started industrialization. And since then, the concentration has gone up to 415 parts per million today. Wow. So it's up by nearly half as much again as it was before the Industrial Revolution. And that is entirely due to human activity. I think that's quite a shocking number.
Right. So another question, Jo, some people might see climate science as something distant or disconnected from on the ground work, advocacy to tackle the climate crisis. And I'm wondering what you see as the connection between the two and how the former should be influencing the latter.
Well, I think both are very important indeed. And I've been delighted. I mean, I've been working in climate and atmospheric stuff for decades, and I'm delighted to see the action that people are now taking, and it's coming from grassroots, which is really splendid. And so I fully encourage that sort of activity. But it does need to be based on scientific evidence. So people can't just decide what they want to about climate. Some people try and do that. Donald Trump is one of these. But you have to base your activity on what we know and understand about climate and climate change. And some of that is more certain than others. And the scientists are able to provide that sort of information. What scientists sometimes struggle in doing is talking about their scientific results in a way that just normal people can understand. So I think, the activists need the scientists and the scientists need the activists too.
Right. Jo, what from your own climate research or experiences has given you some hope about our ability to tackle this crisis?
Well, a long time ago, back in the late 70s and early 80s, I was working on stratospheric ozone, and we were trying to understand what chemicals going into the atmosphere would do to ozone, and we were predicting some decreases. But we didn't predict the ozone hole, and that was discovered in 1985, and the decrease was far bigger than any of us had been thinking. That was quite a shock. And the science advanced, and very soon it was understood that the mechanisms whereby human chlorine compounds were creating the ozone hole. So that was published in 1985, and by 1987, there was the Montreal Protocol, which was a United Nations agreement, a unanimous agreement of all countries to do something about it. And since that time, the decrease in production of the hazardous ozone depleting substances has been remarkable. So that is an example of humans deciding to do something because they can see that they're harming the environment. And I would like to use that as a model for what we can now do about greenhouse gases.
Well, Joe, I think that might be all we have time for, but thank you so much for being here. This has been wonderful.
You're very welcome.
And Tipping the Scales is hosted by the Global Returns Project, a charitable campaign to fund not-for-profit climate solutions at scale. To learn more about our efforts, you can sign up for our newsletter at www.globalreturnsproject.earth. Thank you.